In this talk, I will describe the iDigBees digitization project. Its primary goal is to complete the digitization of bee holdings in US collections. We just recently submitted an ADBC TCN proposal, but we have aspirations of expanding this project globally. There are 33 US collections involved in 4 non-digitizing institutions that cover robotics, biodiversity informatics, and education. This map shows the distribution of participating collections and their target goals for digitization. We were not able to include all US collections with bee holdings in the TCN proposal, although a number of collections have already digitized all or most of their holdings, as indicated by the green stars. There are also several significant inventories either planned or underway, indicated by the purple stars, that should contribute well over 1 million additional records by 2025. Our goal is to transcribe 1.8 million specimen records and produce 53,000 high-resolution image suites. The figure on the left shows 2 simple gap analyses. Both estimate the degree of completion in documenting species presences in pixels about the size of Delaware, and there are 845 pixels in the US for this analysis. Pixels vary in color from red indicating complete to yellow gold, 75%, and then blue, 50%, and less. So the white pixels indicate that there's not enough data to compute a completeness metric. So current completeness using 1.8 million records that were available shows a number of gaps in the United States. Estimates for 2025 indicate that we should achieve about 70% completeness on average across the US. Although this is an overestimate simply because we cannot account for undescribed species, which may consist of 10% of the fauna. The table on the right shows our targets for each of the 7 families with 1.8 million total records, and they're distributed proportionally based on the number of species in each family. There are so there's 1.8 million records, including 1.2 million records for the US, which means about 600,000 records, primarily non-North American. There are 2.8 million records currently in scan, and we expect there will be at least 5 million total records from everybody by 2025. Regardless, we will make significant contributions across all families. The figure on the left shows the number of species divided into 6 abundance classes from less than 30 records per species to over 2,500 records per species. The number of records is an important metric for things like ecological niche modeling, and we expect most of the species by 2025 will have well over 100 records per species on average. We also expect to have 1.8 million total records from iDigBees and other projects collected before 1970 for North America. But regardless of where your cutoff is for historic reference points, we will have a lot of historical data. We have established a DNA barcoding working group consisting of a coordinating lab run by Michael Brandstetter at the USDA ARS Bee Lab in Logan, Utah, and 5 other labs distributed throughout the United States, which will process samples from the entire network. The 2 primary goals are new species discovery and reducing taxonomic burden. And 3 specific goals for the project is to first identify gaps in existing DNA barcode data for bees in North America, 2, develop protocols for bee barcoding and for sequencing degraded museum samples, and 3, generate sequence data for up to 6,000 specimens for barcoding and 600 specimens for ultra-conserved elements. We will use lightning bug technology in iDigBees, which is a robotic software process for semi-automated digitization. We are not ready to deploy the full lightning bug system with moving cameras. We will deploy a light version with one fixed DSLR camera and a moving turntable. But even then, we should process specimens at least 4 times faster than direct human transcription and provide specimen images as well. We will deploy 10 of these units to the larger collections in the iDigBees network. Here are 2 images of the turntable, which is 3D printed, motorized and connected to the same laptop as the DSLR camera. The video on the left shows loading a pin specimen on the stage, held in place by a magnet. You don't need to adjust the labels as long as there's at least a 1 millimeter separation between the labels. The video on the right shows how the specimen and the labels are imaged at 6 preset stops, but you can either decrease or increase the number of stops that you want. The primary purpose is to image labels, but we will also obtain medium resolution specimen images. We expect about 500,000 specimen image suites from this. And this shows the team of Lightning Bug the US core team. We've been meeting for about 1.5 years, maybe 2 years, about once a month, and we will continue these meetings for the foreseeable future. The figure illustrates the basic workflow. So once label images are obtained, they're run through OCR, HCR, optical character recognition, handwritten character recognition, and checked by both humans and artificial intelligence processes. Then the data is converted into parsed into structured text and then transferred to data providers' database and eventually sent to scan. Concomitantly, images of the specimen are linked up with the records and stored in scan and sent to GBIF and iDigBio. Our workflow builds off previous TCNs and includes existing scan functions that we'll improve on, the light blue, third-party processes that are in medium blue, and new iDigBees functions that are in dark blue. Linked to this is a plan for making data more available and open to a collaborative R environment. First, we are developing and fine-tuning a process for pulling data from scan into a database outside the portal, creating a dashboard to inform users about data availability, and R Shiny and R packages that can perform a variety of analysis. Now, the extended specimen concept will be promoted in all iDigBees activities, but especially in our education programs, as this slide illustrates. So, in other words, linking as much relevant information to the specimen as we can. We have outlined 3 education outreach programs. First, we've identified 86 existing activities already offered by iDigBees institutions, and we will provide each of them with specific bee content from iDigBees. Second, Anna Monfils will focus on undergraduate education and coordinate iDigBees module development and distribute that through the Biodiversity Literacy in Undergraduate Education Network, or BLUE, which is a NSF-funded national program. Third, Ann Basham will target high school students and extend her work She's developed with augmented reality and phone apps to explore extended specimen concepts. I would like to end by saying that I hope to extend this effort globally by linking with other efforts and sharing the iDigBee model with other countries. So with regard to linking with other efforts, the distribution of occurrence points for apids shown here from GBIF underscores that there are significant efforts in other parts of the world, suggesting it is possible to realize a global bee digitization project, and then hopefully iDigBees can serve as a model for other arthropod groups. With that, thank you.